Hello again. In this lesson, we will be discussing another important property of fluids. Have you ever wondered why when you're pouring water from a cup, it flows faster than when you're pouring honey from the same cup at the same temperature? Or why it is easier to stir a cup of tea than it is to stir the same quantity of oil in a cup? In everyday terms, we just say that one liquid is thicker than the other. In physics, we refer to this property as viscosity. Viscosity is the resistance to motion in a fluid. This resistance might be resistance to an object moving in the fluid, or even resistance to the motion of different layers within the fluid. Now, thick fluids, like honey for example, have strong intermolecular forces of attraction, which we referred to in the previous lesson as cohesion. This is what leads to their high viscosity. But where the cohesive forces are low, like in water, the fluid is said to have low viscosity. Now, if a stone is dropped into a fluid, the downward motion of that stone will be opposed by the viscosity of that fluid. The more the viscosity of the fluid, the slower the stone will fall due to greater resistance to motion. Now, this opposing force to objects moving in fluids is also known as fluid friction or viscous drag. To show the effect of viscosity, let us use an illustration. If we dropped a steel ball into a viscous liquid, it will be acted upon by three forces. First of all is the weight W acting downwards. Next is the upthrust U of the liquid acting upward, and this depends on the object and will be addressed further in subsequent lessons. Third is the force due to viscosity, which always acts opposite to the direction of motion of the object. In this case, its direction is upwards. This force, Vd, is also known as viscous drag or fluid friction. Now we can therefore say that the total force F acting on the steel ball is equal to mass m times acceleration a. This is also equal to the weight minus the viscous drag minus the upthrust, written as W minus Vd minus U is equal to ma, where remember we said a is the acceleration of the ball and m is the mass of the ball. The viscous drag increases with the speed of the ball. So as the ball falls faster through the fluid, the drag increases until the ball stops accelerating and falls with a constant velocity or terminal velocity. At this point, acceleration A equals to 0, which now implies that Vd is equal to W minus U. So we can say that terminal velocity is the maximum velocity an object falling through a fluid can obtain when the viscous drag and the upthrust is equal to the weight of the object. Now, this process is the same for any object falling through a fluid, like raindrops falling from the sky, achieving terminal velocity before reaching the earth, or even more exciting, the terminal velocity of a skydiver after jumping out of a plane. Now, so far in this lesson, we have learned about another property of fluids called viscosity. Viscosity, we said, is the resistance to motion in a fluid. We also said that an object falling through a fluid will start with the acceleration due to gravity and gradually decelerate due to upthrust and viscous drag until it reaches a constant velocity known as the terminal velocity. So in the next lesson, we will learn about the factors affecting viscosity and further applications of viscosity. Keep learning and we'll see you soon.